Hi, I'm Rakesh, a PhD student at Cornell University. Thank you for shortlisting the paper. So, before we delve into the research, let me show you how a user engages with a B2B platform. So, users are typically sellers who are small and medium sized businesses. Think of them as a small company making whiteboards for classrooms. When the seller logs into the platform, they will see a page like this, where a list of buyers is presented in a sequential order. In each of these tiles, the seller can see what the buyer wants in terms of product, quantity, location, and so on. An example could be I want 100 whiteboards delivered to Seattle by Informs. Now, the seller scrolls through this list to find relevant buyers. If they find one, they can click on the contact buyer button, get in touch with the buyer. Now, most B2B platforms all over the world are investing in large data science teams to continuously improve the rankings. The goal is to show the most relevant buyer at the top of the page. Now, the platforms have two key questions to answer. One, how to periodically assess the quality of rankings. And two, how to examine the effect of improving ranking quality on usage and effort. Usage is basically the number of clicks on the contact buyer button. Effort is the total number of tiles the seller sees from the top. Now, we use a vast amount of real time rank transaction data accessible to platforms to answer these questions. Now, what is this real time rank transaction data? It is basically a set of positions where the seller clicks on the contact buyer button. An example from 3 sessions is here on the screen. So, in session 1, the seller clicks on the contact buyer button at positions 3 and 4. And this is what you see on the image with green ticks. Now, the position numbers provide a rich input to answer our questions, but the data has two issues. First, it is confounded, and second, it is censored. I'll not get into confounding, but let's briefly look at censoring. Censoring happens because we do not see positions that are viewed after the last transaction. So consider session 3. If the seller had ended the session at position 5, the data would have been 1, 2, 4, and the information that position 5 was seen would have been missing. Now, the way we overcome this problem in measuring ranking quality is to restrict the construction of our measures to the top 3 positions that are always visible to the seller without effort. Now, we collect transaction data from the top 3 positions and construct a counterfactual perfect sequence. So, in the example on the screen, the transaction data suggests that buyer C should have been placed at the top of the list, which is what we denote in the counterfactual sequence. Now, our measure of ranking quality then is the difference between these two sequences measured as the Kendall-Tau coefficient. Now, how do we measure the effect of ranking quality on usage and effort? So we do this by constructing a position level model. So at every position, the seller is making two decisions. So should I transact and should I scroll forward? So the approach we take is to write the probability of these two decisions as a function of ranking quality and come up with ways to overcome censoring in estimating these probabilities. I'll show you a glimpse of one approach and quickly get into the findings. So essentially, the idea is to construct sample paths. For example, let's say this is the data we observe. Now, the probability of us observing this data is the sum of all possible sample paths that the seller could have taken to generate this data. For instance, the seller could have ended the session at position 5, or the seller could have ended the session at position 6, and so on and so forth. So we maximize the summation of all these likelihoods. So after doing all of that, what do we find? What we find is that improving ranking quality increases usage and decreases effort. And let's see what's happening behaviorally with two examples, one with perfect ranking and the other with not so perfect ranking. In perfect ranking, the moment the seller sees the position 5 is not relevant, the mental model is that the platform seems to have done a good job at ranking so far, but it did not show a relevant buyer at position 5. It means that nothing after position 5 is relevant, so I will end the session. Now, this mechanism ensures that usage is maximized and effort is minimized in a perfect sequence. This seems like a great outcome, but perfect rankings are seldom and there is possibility of lost usage. Now, take the example of a not so perfect sequence. In this scenario, the same behavioral mechanism will make the seller end the session at position 4 when there is a relevant request at position 5. So, what we are recommending to the platform is that there is some value in nudging the seller to view a minimum number of positions and pairing these nudges with the efforts to improve ranking quality. So finally, I'll leave you with what you should expect from a longer version of the talk and the paper. So three additional things that you should expect. One, of course, the methods to overcome censoring and the confounding problem. Second, we are currently testing the idea of scroll nudges with a behavioral experiment. You will see those results. And finally, there are 723 product categories on the platform, and you will see some results on heterogeneity in response to ranking quality across them. With that, thank you very much. I look forward to seeing you at Informs.